The Manta Ray unmanned underwater vehicle prototype built by Northrop Grumman completed full-scale underwater testing off the coast of Southern California in February and March 2024. Since then, new reports on the project's progress have surfaced, but participants have kept details under wraps. Now, additional information has come to light that adds to the big picture and reveals some of the technical features of the project. They're truly unique. And maybe this project will be a crucial link in Taiwan's defense against Chinese expansion. To learn more about Manta Ray and what Taiwan has to do with it, watch this video to the end. It's going to be interesting. The Manta Ray unmanned underwater vehicle has been developed by Northrop Grumman since 2020 under the DARPA program. Recall that the Defense Advanced Research Projects Agency, or DARPA for short, is the central research and development agency of the U.S. Department of Defense. It was created in 1958 by President Dwight Eisenhower in response to the launch of the first artificial satellite by the Soviet Union. Among the technologies that have been developed with DARPA's involvement are important inventions such as weather satellites, GPS, unmanned aerial vehicles, stealth technology, voice interfaces, personal computers, and the internet. At the end of 2021, the preliminary version of the Manta Ray project was approved by the customer, so the Pentagon moved to the final part of the program where its competitor was a similar development from Pakmar Technologies. The project is named after the Manta Ray, the largest stingray in the world, whose mass can reach as much as 3 tons. During 2022-2023, Northrop Grumman successfully completed the project and began construction of the prototype. On April 8, 2024, the development company reported building a prototype Scud for testing. Details of the plans and past or planned work were not disclosed at the time. The official news was accompanied by a photo of this underwater vehicle taken on land in such a way as to hide all the main features of the design. Technical details, for obvious reasons, were also not disclosed. Less than a month later, on May 1st, the agency DARPA told about the progress of work. According to its report, the product Manta Ray has already passed full-fledged sea trials. Moreover, these events took place in February and March, so a few weeks before the company developer reported the existence of a prototype. DARPA also published some interesting photos from the tests. Manta Ray looks like something between a B-21 bomber and a real manta. A satellite photo of the Port Hueneme Naval Base in California taken by Google Earth last November has recently appeared on the internet. The photo shows a floating pier with several piers. On one of them, there's an object of unusual shape. It looks like an autonomous unmanned underwater vehicle, the Manta Ray. The object is secured in place by several ropes. Additional buoyant elements have been added in front of its bow to hold it securely and facilitate access to it. There are boats and motorboats near the Scud, which allows us to infer its size. We can guess that the apparatus is about 10 meters or 33 feet long and has a maximum width of about 13.5 meters or 44 feet. The height of the apparatus is determined by its vertical planes and probably exceeds 2 to 2.5 meters or 6 to 8 feet. The development company didn't report the existence of the Manta Ray prototype until 4 to 5 months after its launch, and DARPA withheld information about sea trials for a month or two. Even though some information about the activities was published, the main information about the project remains classified. This behavior of the two organizations is completely understandable. The program of development of heavy autonomous unmanned underwater vehicles is of great importance for the U.S. Navy, so the work's conducted with the necessary secrecy. As a result, there is very little official information about the project. Perhaps as the competition progresses, new information will emerge. The recently released images can be seen as a kind of third-party leak that has nothing to do with the project. It's not known if the client and developer are concerned about the satellite photos becoming public. Most likely, they don't consider it a problem because the images are of low quality, do not allow it to determine the technical features of the AMPA, and so on. For example, test photos published in May showed much more details about the design of the vehicle. Official data on the Manta Ray project and previously published photos help to get a general idea of the main technical characteristics and capabilities of the prospective autonomous uninhabited underwater vehicle. And it was already known the product Manta Ray has a similar shape to a Stingray or a flying wing aircraft. Along the entire length of the vehicle is an elliptical hull, which houses the main units. The nose part of the apparatus forms a kind of wing swell. On the sides of the body, attached to the arrow-shaped arms with a straight trailing edge. In the tail section, 2 vertical planes are provided. The overall shape of the vehicle indicates that it's designed for the most energy-efficient glide in the water, not for top speed. DARPA reports that the Manta Ray utilizes the principle of planning by varying buoyancy. Controlling this parameter should change the depth of the stroke, and wings turn vertical movements into horizontal ones. So a fundamentally new kind of movement underwater is used. It's indeed a kind of flight underwater. All systems of the vehicle are powered by high-capacity batteries, making it fully electric. Various measures have been taken to reduce energy consumption, such as planning motion, which reduces energy requirements. In addition, the vehicle can lie on the bottom and remain there for the required time with minimal charge consumption. A concept for underwater bottom charging stations has also been proposed that would allow the recharging of batteries during a mission. A unique control system has been developed for the Manta Ray that can autonomously control the vehicle during long missions and utilize specialized equipment. This system probably includes an autopilot and navigation instruments adapted to the Stingray's movement, as well as communications and other components. In addition to all of the above, the new drone should be able to automatically dodge underwater obstacles. Inside the Stingray, there are spacious compartments for the placement of payloads. These compartments are apparently accessed through covers on the top of the hull. It's not yet been reported what kind of payload will be used and what tasks the new autonomous unmanned underwater vehicle will be able to solve with its help. Various instruments for monitoring the situation and detecting and tracking objects may be used. The use of armaments cannot be ruled out either, given the size of the vehicle and its cargo compartments. In addition to Northrop Grumman, the project is engaged in the company Pacmar Technologies. It has the task of creating a power plant Stingray which could generate energy from the surrounding underwater environment. The drone is supposed to harvest energy from ocean temperature gradients and the kinetic energy of water flow to then convert into electricity. Manta Ray has a modular design which allows the device to be quickly transported to the desired location. Incidentally, the tests also included verification of the vehicle's ability to be assembled in the field, as Manta Ray was disassembled and packed into 5 standard shipping containers before being shipped from Northrop Grumman's Maryland facility to California. The demonstrated ease of transportation and assembly ensures that it can be rapidly deployed worldwide without overloading valuable pier space at naval facilities. Following the test, DARPA Program Manager Kyle Werner stated that successful full-scale testing of the Manta Ray validates the vehicle's readiness to advance to real-world operations following rapid field assembly from modular subsections. The combination of nationwide modular transportation, field assembly, and subsequent deployment demonstrates a unique capability for an ultra-large autonomous unmanned underwater vehicle. Delivering the vehicle directly to the intended area of operations saves energy that the vehicle would otherwise expend during transit. Once deployed, the vehicle uses efficient planning to navigate in the water. The vehicle is designed with multiple payload bays of various sizes and types, allowing it to fulfill a wide range of naval missions. So what specific missions will the Manta Ray be tasked with? It seems to us that the main task will be to search and destroy submarines and surface ships of the enemy. The Mark 54 Mako torpedo can be used as the main weapon. Its development began in 2000. The first samples entered service with the U.S. Navy in 2003. A torpedo is launched using a rocket booster from a special launcher and ballistically flies in a given direction without steering. At a predetermined location, the torpedo is separated from the rocket booster and the torpedo is parachuted into the water. After that, the piston engine with external combustion is switched on and the torpedo goes on a search course against submarines and enemy ships. For this purpose, it's equipped with the active and passive hydroacoustic homing system. The weight of the torpedo is 276 kilograms or 608 pounds, including the weight of the warhead, 44 kilograms or 97 pounds. It's 2.715 meters or 8.9 feet long, and 324 millimeters or 12.7 inches in diameter. As you can see, the weight and size characteristics allow for this torpedo and more than one to be placed aboard the Manta Ray. The speed of the torpedo is 40 knots, so higher than the speed of any surface or submarine ship. The range is 9.1 kilometers or 5.6 miles. Now let's move on to Taiwan. U.S. intelligence believes that Xi Jinping has ordered the Chinese army to be ready to take over the island by 2027. By that time, unless something extraordinary happens, the combat potential of the Chinese Navy will be higher than the American one. In any case, the battle for Taiwan, as computer modeling shows, will cost the U.S. Navy up to half of its attack submarines, 1 or 2 aircraft carriers, and thousands of American sailors' lives. Now imagine that there will be hundreds, maybe thousands of manta rays waiting for Chinese ships near bottom charging stations near Taiwan. Then the bloody sea battle would turn into a beating of the Chinese fleet with virtually 0 casualties in manpower for the U.S. fleet. Maybe it was the manta ray that U.S. Indo-Pacific Command Head Samuel Paparo had in mind when he said the U.S. would deploy thousands of unmanned ships to the Taiwan Strait to stop a possible Chinese invasion. I want to turn the Taiwan Strait into an unmanned hell using some classified capabilities. Such a response will follow if the Chinese Navy crosses the 100-mile zone on the approach to the island. Yes, there's very little time left, no more than 3 years. But American scientists, designers, and industry have repeatedly demonstrated that they are capable of miracles. That's why 1,000 manta rays does not look like some fantasy. Look at Ukraine. With 1,000 times fewer capabilities than the U.S., it's managed to build dozens, if not hundreds, of unmanned ships in a short period, which have already destroyed a third of the Russian Black Sea fleet. What do you think about the Manta Ray unmanned underwater vehicle project? Will it take part in the battle for Taiwan? Share your thoughts in the comments. We'd be glad to get a thumbs up and subscribe to our channel. See you soon.